Hello students, we're back with more about measuring angles and arcs. So today we're looking at arcs again, but instead of talking about the measures of the arcs, we're talking about the lengths of the arcs. So the first question is, on this circle, what is the length of arc AB? So the answer is not 90 degrees. 90 degrees, that central angle measure, tells us that the measure of the arc is 90 degrees. But now we're asking, if you were on this circle standing at A and you walked around the circle to B, how long of a walk is that? So you may want to pause the video there and see if you can reason out how you could do that. I bet you could actually. If you give yourself a minute, I bet you could figure out how long it is to walk from here to here. So you may want to hit pause, but here I go. We said yesterday the circumference of a circle is the diameter times pi, so in this case 12 pi. Walking all the way around the circle would be a length of 12 pi inches. But we're only going part way around the circle. The question is, what part? And hopefully you all quickly recognize the fraction of the circle that we're going around there is 1/4 of the circle. But I want to be really clear and even back it up a step. The reason it's 1/4, that fraction comes from 90 degrees out of 360, which we know simplifies to be 1/4. So we want that fraction of the full circumference, that fraction of 12 pi. So if I simplify 90 over 360, it's 1/4. And I multiply by 12 pi, which of course is over 1. So I can multiply the numerators to get 12 pi. I multiply the denominators to get 4. 12 divided by 4 is 3. Final answer, 3 pi inches. That's how long it is around the circle from A to B. Just a fraction of circumference. So why don't you take a look at the second one, get a good look at it, pause the video, give it a shot, and then we'll come back and I'll show you. So once again, we'd start with the fact that the circumference all the way around would be 8 pi. But if I'm only going from R to S, that's going to be a fraction of that. And for some of my students in the past, the hardest part of this lesson has just been dealing with the fractions, for better or worse. That's been the hardest part for some of them. So 150 out of 360, that's how much of the circle I'm looking at. I'm going to multiply that by the circumference, which is 8 pi. So it's again literally this fraction of the circumference. Now you could multiply your numerators together and get 1200 pi. The denominators would be 360 times 1, which is 360. And you could simplify that, you'll get the right answer. I think it's easier to simplify first. For example, common factor of 10 here, divide both parts by 10, knock off the zeros. 15 over 36, that fraction simplifies. There's a common factor of 3. Divide both parts by 3, we get 5/12. I can also simplify this 8 in the numerator and that 12 in the denominator. The fraction 8/12 has a common factor of 4. So divide both of these by 4 and we get 2/3. There's no more simplifying I can do with any numerator and denominator, so now I multiply across. My numerator is 5 times 2 times pi, 10 pi. Denominator is 3 times 1, 3. My units were centimeters. That's the answer. If it said to round off, we'd grab the calculator, but it didn't, so we won't. I know I did that maybe quickly, but you can rewind and watch again. Here's the last one. Take a look at that. Hit pause after you give it a shot. And here's the deal. First, did you notice I asked for the length of arc YZ? YZ is not this arc. YZ is this arc. So this is what I asked you to find. Now I actually did this on the back. So the length of arc YZ would be a fraction of 140 out of 360. That 140 comes from this linear pair. So I know this arc measure is 140. So I want that fraction of 9 pi. And I divided both parts by 10. I simplified again, divided both parts by 2. I also simplified this 9/18 to become 1/2. And final answer, when I multiply numerators and denominators, is 7 pi over 2. So feel free to pause and get a good look at that if you need to. Last thing for today is just be aware that in your book there is a typo. If you happen to be assigned from page 568 any of the first 4 problems, the book says to find the measure of each arc, but if you were to check the odd answers in the back of the book for these two, they don't give you the measures of the arcs, they're giving you the lengths of the arcs. So make sure if you're assigned any of these problems, you're aware of that typo. Good luck.